Cool. Yeah, let's get started. I'm Shomil. I'm at Anyscale. I'm a software engineer. This is Bruce. And we're going to talk about kind of the architecture that we work with at Anyscale. So just to set some context, at Anyscale, we are managing millions of concurrent cores, CPUs and GPUs every day. That's over 10,000 Ray clusters, thousands of developers, and we're doing this globally on many different providers in many different cloud regions. Today, we're going to kind of talk about our different deployment architectures. So we deploy on cloud VMs, we deploy on AWS, GCP, Azure, a lot of different cloud providers. We deploy on-prem, and we also deploy on Kubernetes. So we have a lot of flexibility in how we deploy, and we'll walk through the architecture that we've used to kind of build out these deployment schemes. So to start out, let's talk about our kind of first offering that we built out, which is this native cloud provider support. And so this is directly leveraging cloud VMs to kind of do our orchestration and run Ray clusters. So kind of the most basic unit of compute that we get from these clouds is the VM, right? You can use the EC2 API or the GCE API and kind of acquire an instance and run whatever you want on the instance. And so we started with this as our foundational architecture. We kind of have an instance manager in our control plane, which kind of runs in Anyscale's account, and a daemon in the data plane, which runs on the instance when we launch the instance. And the two of these kind of work together such that we can run Ray clusters where the daemon is essentially managing the container and the instance manager is managing the instance. Directly working with VMs gives us like really high throughput capabilities because we are only constrained by the cloud APIs. So, if you want to scale up like thousands of nodes in minutes, we can do that as long as EC2 or GCE gives us capacity to do this. Because we're working with the cloud APIs, we also get really intelligent failures. So we can kind of look at the error messages that the cloud APIs are giving us. So if it's like a out of capacity error or this zone doesn't have enough quota or something like that, we can kind of take these into account and make better decisions in our auto scaling and our scheduling layers. In the data plane, we also, working directly with VMs, can do things like really fine-grained C-group isolation. So in Ray, one of the most common kind of issues that you run into at scale is that your workload kind of knocks out some of the Ray system processes that you want to keep alive at all times. So this is like the Ray worker process might knock out the Raylet, for example. What we can do at Anyscale is essentially set C-groups and protect both the Ray components and the Anyscale system components such that the workload will never take down the kind of system components and our orchestration can stay alive even if the application is crashed. Another thing that we can do is detect GPU failures. We can probe the GPUs, look for health checks, make sure that we cycle them out when those fail. We can do disk pressure eviction and spot preemption. So we kind of have all of these features built out over the years as we've seen different kinds of failures and failure cases, and we've dealt with all of these. So like I said before, working directly with the VM API gives us like really high scaling capabilities. And so just this past few months, we've been able to reach 800,000 CPU cores in a single Ray cluster. So that is like 8 to 10,000 nodes in a single Ray cluster, working with, directly with the Ray core team on scaling GCS and scaling the Ray dashboard, in addition to working with our control plane to kind of scale our instance management and our data plane capabilities kind of holistically. And when you start hitting this kind of scale, 10,000 nodes in a single cluster, you run into kind of different problems as well. So one of these is that you have to go across multiple node types, multiple zones potentially, market types. And some of our customers are opinionated about the shapes of instances that work better in these workloads. But they do need to try many different types of instances. And so we have this group ranking kind of feature that we built out where autoscaler is able to take into account user preferences when they're autoscaling. And we can say, always prefer the kind of standard high CPU options that GCP provides. And when we're exhausted those, then fall back to like the disk, the ones that come with attached disks, which are more expensive, slightly more expensive, but like at this kind of scale, that few extra cents there on the dollar won't really make a difference. And so they want to fall back to those kind of other instance types. And the other kind of really useful feature here is being able to go backwards. You know, when those cheaper instances open up, or there's capacity for those, we want to go back and evict the kind of like more expensive ones, and so we kind of do that as well. Another thing that we run into at 800,000 CPU scale is, you know, we have these kind of really edge case EC2 failures that we see. And this, you know, GCE has their own class of failures. But this is something like the instance has some hardware failure that, you know, it's not the user's fault that this happened. It's just something happened at the cloud layer. And, you know, we need to kind of surface this to the user. And so this is something that we added recently where we monitor for these types of failures and we surface them to the Ray application so that the developer knows, why did my Ray application crash? Why did my process crash? So that's kind of like the basic VM offering. And recently we've also expanded this into supporting multi-provider and multi-region deployments as well. So at large scale, some of you may have seen that you know, a single region or a single zone may not be enough, and you need to go across the region boundary and potentially even across the provider boundary to find the compute that you need. And if you've heard of SkyPilot, that's kind of an open source solution to this. They've been kind of working on this in the open source. We've also been working on this on the Anyscale product, where we can kind of take this in two different approaches that we've done. One is kind of the cloud and resource management side of things. So when you go from one region, one provider to N regions and N providers, you have to deal with a lot of cloud resources. And so we've kind of abstracted some of that away, made it really easy for you to go from one to many. And at the auto-scaling layer, we also need to be able to make intelligent decisions and, you know, find the regions and providers that have capacity and, you know, have global views of which ones do, and we kind of manage that layer as well. And, you know, kind of going a little deeper on that, sometimes like a single workload itself needs to scale across the region boundary. Let's say that you're running this really big job, you're out of GPUs in one region, you need to burst to multiple regions. And so at this point, you need to take the Ray cluster itself and make that go across the boundary. And so that's also something that we've done, where, you know, your head node might be running in US East 2 on AWS, and maybe you need this special type of GPU that's only available at the time in US West or US East 5 in GCP. And so something that we can do is we can use overlay networks, which is this kind of networking abstraction over the VPC to make the connectivity work between these nodes. And, you know, if we tweak a few other attributes of the Ray core layer and the scheduling layer, we can get this really nice capability that allows us to burst beyond a single VPC and a single private network and go into multiple places. And so two particular strategic tweaks that we made when we did this is that we disabled head node scheduling, which is really important to essentially prevent a lot of inter-region network traffic. And we also added more intelligent kind of pack strategies in our auto-scaling. And so one of the things that we do is we say, you know, maybe this set of workers has to be packed together in a particular zone or a particular region, you know, but they can be somewhere different than the head node. They don't have to be in the same place as the head node, because we know as the application builders, we know that this group of workers kind of has a lot of inter-node connectivity, and we don't want to have that connectivity go over the region boundary. And so this gives us really good abilities to give people the power to try out multiple accelerators and kind of use GPUs that are in lots of different places. And so when you cross the provider boundary, you run into this other issue of, you know, like now these users are dealing with both AWS, GCP, potentially other providers as well, and you have all these instance types. And so from a developer experience point of view, kind of remembering that, you know, a 10G on one provider versus another provider is called something slightly different is kind of hard. And so we have this kind of accelerator-driven auto-scaling where we have in the Anyscale UI, you just check this box, the auto-select worker nodes box. And under the hood, we've mapped, you know, a lot of accelerators and different kind of preferences for instances into the actual instance types. And so the end users don't actually care about the underlying types. We, on the infra side of things, kind of abstract all of that away. And another thing that we've kind of seen, kind of extending this multi-cloud, multi-region universe, recently is that some of our customers have on-prem deployments as well. So we kind of want to go into this territory. So we built Anyscale Machine Pools to kind of address this. The motivation is pretty simple. It's, these businesses want to use like cheaper hardware. Sometimes it's our customers, sometimes it's ourselves internally. Our own development teams want to use H100s that are on a third-party provider or on-prem. And they're saying, how do we use these on Anyscale? How do we integrate these with the rest of our array deployments that are running in these different places? And so when you kind of move into the on-prem territory, you have to deal with a separate set of infrastructure challenges that weren't kind of existing before in the VM world. One of them is this, the main one is this lifecycle management. It's the fact that you now go from having the cloud provider take the instance and kind of reset all the state to us having to do that on the infrastructure layer. So we have to do all the state management. Another is that when we run on top of customer bare metal hardware, there's a lot of security requirements that come by. They say, hey, you can't run as root. So we have to have this rootless support, something like that. And when you are using physical hardware that's kind of in the office or in the data center, you have this resource sharing issue. There's a fixed number of boxes, you can't really autoscale, and so you want to essentially create some priority preemption between different workloads. So we've kind of built support for all three of these things. And the way that we kind of plug this into our existing architecture is relatively simple. We took the kind of cloud APIs, the fundamental cloud APIs for VM management, which is kind of like create node, delete node, and list nodes, and created an abstraction over the physical bare metal machine that allowed us to implement these abstractions with our own kind of management layer on top of the machine itself. Now I'll hand it over to Bruce to talk about our last deployment, which is kind of on top of Kubernetes.
Thanks, Shomil. So after Anyscale has already successfully supported the fancy features we mentioned in VM stack, and also for machine pools, we start to explore another big area of the product, which is Kubernetes stack. So we started looking at the OSS solution, which is Kubernetes. And people can run their Kubernetes operator in their Kubernetes environment, and can manage the array class on top of it. And we summarize several good advantages of Kubernetes. First, it's very easy to install and onboard. You just need a Helm chart command. It will be set up. And second, it's a native Kubernetes support. It's just a Kubernetes operator, manage the CRs inside the Kubernetes environment. So third, it can coexist with other resources, other namespace and application together. And the last, Kubernetes is installed in user's data plane. So it provides very good control and high security. So we're considering that we should extend all those advantages and merge it with all the proprietary features that Anyscale provide. So here, we introduce Anyscale operator. So on top of Anyscale operator, it can manage hundreds or thousands, whatever number of array clusters, and it combine it with all the fancy features of Anyscale provide, such as manage the log metrics, GPU health check, authn and auth support for array dashboard, and for service, manage the GCS for torrents, which can survive even a handled crash. And also read-turbo with a lot of good features of, let's say, fast machine learning model download, complex scheduling for reserve, and all those proprietary features provided by the read-turbo. And also has better scale and better performance. And under Anyscale operator, it's powered by Anyscale platform. It has all the proprietary features like persistent log history, Anyscale service HA rollout, Anyscale console, UI, SDK, and CLI. And also, it has good observability, include Grafana of org level, cloud level, workload level. You can do cost management, you can do admin control, you can do permission control, you can do budget, usage, and everything. So let's see another figure. So this one shows the Kubernetes can be installed in any kinds of Kubernetes environment, which include EKS, GKE, AKS, and self-hosted Kubernetes. And the Kubernetes operator just run in the namespace and work together with the array autoscaler to manage the parts. It coexists with third-party applications. And when we introduce Anyscale operator, it looks like this. It just replaces the Kubernetes operator in the same Kubernetes environment, can run on top of any Kubernetes environment. And what we do is we also move the smart component like array autoscaler to Anyscale control plane. which is the smarter part, provide all the proprietary feature we just mentioned. And the Anyscale operator can also coexist with all the other third-party applications. Let's take a deeper look. First, how can we install Anyscale operator? It's just a super easy two-step. First, register an Anyscale cloud. It will give you some output of the metadata. And then you run the hum command to install the Anyscale operator. Then it's done. The hum command will create an assigned namespace in your Kubernetes. Like the red figure shows, the Anyscale operator will manage only the resources within the workspace. And it provides very good isolation, coexist with other namespace and the resources. And the Anyscale operator will start to have outbound calls to Anyscale control plane, which provide all the smartness, provide good operations for cluster orchestration decisions, and the Anyscale operator will execute all the operations in the data plane. And this traffic is egress only. And even when the connection between Anyscale control plane and Anyscale operator is temporarily broken, it's fine. Anyscale operator can keep managing all the resources in the data plane, keep them running as is, and once the connection is re-established, Anyscale operator can resume all the operations it needs to do. So now, let's go to a live demo to see how the Anyscale operator can be installed and works. So it has 3 steps. First, we will show how smooth to install Anyscale operator. And then we will show you some customized config map that you can use to make it very flexible. And last, we will show some real workload, a half rollout canary service with 2 versions, and also a workspace with a stable diffusion workload in that. So let's go to the demo. So now assume I already have my Azure AKS set up. So here is the Anyscale UI, what it looks like. And here you can click and see the list of the cloud. And then let's go to the terminal. Here, today, I want to demo and create this as my new cloud name. So I will copy the cloud register command to my terminal and just run it. And during its run, let me explain what will happen. So here, the command first, you need to include the cloud name. And then, because it can support all kinds of environment, so we say the cloud provider is generic. And this is for Kubernetes stack, not VM stack. And we will assign it a Kubernetes namespace. The namespace is same as the cloud. And I also put the IP address of my ingress controller, which I used for access my services and node. It can be a private IP in private VPC or public, depends on your setup. And once the command finish, the important output is this cloud deployment ID. So the second command I have copy here is this hum install. So I just replace this placeholder with the cloud deployment ID output from the previous command. And just run it. It will install the Anyscale operator and create a namespace. Let's for it to finish. So here, it's done. It's super fast. And then when we see the Kubernetes namespace, we can see this is a new namespace we just create. And let's see what's inside. We can see there is already running the Anyscale operator. And go to the UI page. We can see this new cloud is appear. And you can switch to that and start to use it. And to save us time, I already started the workloads in a cloud I created this morning. And in the UI, you can see that Anyscale provides you all the selection for the types that you just defined. And you can also do this auto-select nodes. I will demo it later. So let's go to my morning creator Kubernetes namespace and see what's in there. So I will run a script to show the resources in this Kubernetes. So first, I want to show the instance type config map. So it's a place where you can define all the instance shapes you have. It's very similar to Kubernetes part shape, but the Kubernetes you need to define it for any, like say, CR. And here is a config map that is global reusable. For example, here I add 2 special instance types, one for T4, which has actuator type T4, and one for 8NG. So I want to specify these two specific GPU type for me. And then another config map is the patches. It gives you very high flexibility that you can customize what Anyscale operator should manage your Kubernetes environment. So let's just go to the 2 GPU-related group. So first, the semantics is you can write a selector. It's just like label selector that Kubernetes provides. So here, I will say, if Anyscale say this port is in 810G, I want to add a node selector to put it in my node pool, which is the 810 node pool. If it's T4, I want to put it in the T4 node pool. You can customize it in the UI or put it in the config map. And then in my namespace, I already have 3 ports running. One for the workspace I want to demo, and one for the primary version of the Anyscale service, and one for the canary version of the Anyscale service. And we also set up the ingress for your service, one for primary, one for canary, and 3 for the head node. Each one has 1. And then let's go to the service page. So this is a service I just showed you. It has 2 ports running, each one for the head node, and we can do the query, and it will give you a URL that you can query it. So here, I just copy it, and see it gave me V2 results and V1 results. It means it's from primary or from canary. And you can also put a special header, which is canary, to say it always go to the canary version. It's very useful when you test with CI/CD to verify the canary version works as expected. And that's Anyscale service. Then we go to demo for the workspace. Here, I already start a stable diffusion server, and I just try to send a request to my server in the right side. And when we go to the dashboard, we can see this stable diffusion actor is upscaled from 0 to 1 replicas. And because I configured the head node with 1 GPU, which is 810G, so you can see the left side has a processing bar, which is generating the image with stable diffusion. And once it's finished, we will see the figure just auto-refreshed. This is new generated image with a cat on the green grass. And also, we want to demo that our auto-select worker nodes feature. I already configured my workspace, say auto-select workers. So what I want to do is I want to run a T4 task. Right now, my cluster does not have any T4 GPUs. And I already write the read code to say it requires a T4. So what happens if I just run it? I run this Python, and see it has some log say, oh, right now we want to upscale some T4 machines. And we can see it's already launched on one node for T4. We can go to the read dashboard, see what happened. Here is the job running. And you see it changed to 2 GPU, one for 810G, one for T4. And you can also see the right side, it become 2 GPU, and you can see it's running and idle because my job is very small and it finished. And if we wait for, like, say, about 3 or 4 minutes, because the node is idle, it will auto downscale. Yeah, so that's everything for the lab demo. And let's go to the next page. So here we will announce that Anyscale is ready to supercharge your AI platform. We can support very well for VM stack on AWS and GCP. We can also support on-premise machines with machine pools. We also support all kinds of Kubernetes environments with Anyscale operator and very smooth to install and provide you even more powerful features than Kubernetes. So Anyscale is a scalable and performant array cluster management on any machine, on any platform. Thanks everyone for joining the presentation, and just want to highlight we're also hiring. So if you're interested in what we do in Anyscale, you can go to that URL and look for positions.
All right, we have 5 minutes for Q&A. So if you have any questions, please raise your hand and wait for me to bring the mic to you.
I saw there was support for like priority-based preemption or something like this. Is that preemption at whole job level or like at node level? Can you like borrow pieces of another job if necessary?
Node level primarily, at least for our like infrastructure layer preemption. Sorry, node level. I don't know if my mic was on. I believe we also are building in job level preemption as well for other shapes of workloads. But right now, the kind of most common use case we've seen has been at the node level.
Cool, thanks.
Any other question?
Do you require the control plane to be always accessible? What happens if it's not reachable or something like that, and if it gets disconnected?
Yeah, for all the stacks, the control plane is only for new operations. And if you have workloads running, even if control plane is crashed, all the workloads will not be impacted. It's just that you cannot submit new operations to your data plane. For example, on Kubernetes, if you have 10 RAID clusters running, it's keep running. And it can, like say, also execute and serve all the traffics. And when the control plane come up, you can use Anyscale UI and SDK to maintain it, maybe like say do the upscale, downscale, or create new workloads. Yeah.
I think we have next question.
Hi. Where the control plane is deployed, in which region?
Can you repeat that?
Where do you deploy the
where do we deploy?
control plane?
Go ahead.
Oh, okay. I mean, right now we deploy in AWS. US West 2, just like a particular, just out of chance. But, you know, we have a kind of two-phase control plane. So we have like a global control plane and we have a regional control plane. So the regional control plane is something that we can deploy in any, you know, kind of region across the globe. So when we need to get closer to the actual customer, we can do that as well.
Whatever region. Full flexibility to deploy in whatever region.
Yes, the one thing I will say is that the control plane right now is something that we deploy in Anyscale's account. So it's not something that you would deploy in your account. But yeah, we can deploy it we can deploy our orchestration stuff in different regions if we need to.
Okay, thank you.
We can take a few more questions down here.
Have you had any requests to deploy the Anyscale control plane in an air-gapped environment?
I will have to give that one to my product manager to answer.
Don, you want to take the question?
Have we gotten requests for it? Yes. Is it on our immediate roadmap? No, but we'd love to have a conversation about the priorities and like what exactly would be involved there.
So for the cross-provider array architecture, you mentioned that you disable head node scheduling. Is the intent here really to partner to pair with the array compile graph so that you basically avoid doing as much like head worker communication as possible? Or like, help me understand. Yeah.
Yeah, I think disabling head node scheduling is something that we've been pushing for a long time, especially with like multi-node clusters and when you have like lots and lots of workers. The main goal without this cross-provider stuff has typically been because of stability reasons. Like we want to keep GCS and the array dashboard very stable. So we don't want to have worker processes interfering with them. In the cross-provider case, kind of the reason we do that is because the code has to run, like the driver has to run somewhere, and we have to be able to know what the workers need to actually upscale them. And so we run the code on the head node, like the actual like driver code. But the actual worker processes, like we want them to be all together, and so we put them all into like the same region or the same provider or whatever the constraint is on the compute. And so that's kind of like why we disable. Like we wouldn't want one worker to be over here and one worker to be over there. Yeah.
Got it.
But in general, like best practices are to disable head node scheduling in multi-node clusters. Like that's kind of what we suggest in our docs. That's kind of what we're pushing for in Anyscale as well. Yeah.
Got it. Thank you.
Hi, thank you for the talk. Can I assume like this is a kind of a multi-cluster, multi-hybrid cloud cluster, and then I can federate my workloads across different types of like cloud instances or like Kubernetes environments?
Yes.
Okay, so and in that case, so for example, if I can use it for kind of the heterogeneous cloud cases, right? In that case, is that are you making open source version of that, and so we can adopt this in our own cloud setup?
Maybe I should turn that to my product manager as well. I think SkyPilot is probably like what a lot of people who are strongly into the open source thing use. That's like I would look at SkyPilot.
Yeah, sure.
mean, Anyscale as a platform is designed to have a centralized control plane that can orchestrate Ray across every cloud provider, every location where you're running Ray. Ultimately, our goal as a company is to provide the best services for Ray that fits the workloads of everyone. If you love Ray, we need to exist as a company, though, so like, we need something.
Yeah. I think the other thing I'll add is one of the advantages of doing global scheduling and global autoscaling is that we get global knowledge. And so we know like what capacity exists in what regions in a way that you can't really do if you have like separate open source deployments of SkyPilot across the world. And so that's something that like we've actually found value in because like if we have two customers that are running in the same cloud region, we know where there's capacity and where there isn't.
Right. We can take one more short question. Looks like we're good. Oh. Okay.
If you're interested in trying out any of these capabilities, who do I reach out to? This gentleman right here.
All right. If you have any more extra questions, you can ask Shomil and Bruce after the speak. And thank you everyone for coming. Please give now a round of applause for Bruce and Shomil. Thank you.